I hope you all are done with your lunch.
Yes, sir.
Now, post-lunch sessions are a confusion because half of the students they want to listen, more than half of the students they don't want to listen. I mean, that is quite obvious. So, anyways, we will start. We will move a little slow because obviously after lunch you all will be a little slower. Now, we were talking about transverse framing system, and that is where we will start. Let's see. Let me share the screen. Okay. So we were on. God, here it is. Okay. Okay. So we were here. In the previous class, if I'm not mistaken, we understood the bottom part, how it is different. Am I right? There was no confusion there, right?
No, sir.
Okay. Okay. So confusion started with the side shell. Okay, let's address that. The side shell, a more detailed picture of the side shell is given here. Okay. Now let's see what it represents. First of all, the large side shell is comprising of a number of plates, as we discussed. Those plates have been welded together to form a larger plate. That is a side shell. Okay. These are those smaller plates which have been welded together. Now, if you remember when we were talking about the design of the small stool or the small table, we also said that it is not only important that we strengthen each of the component, we have to ensure a better efficient connection between those members also. Okay. So for that purpose, what is done here is, this is my side shell. The side shell is connected to the bottom plating. They are welded. Steel structure is just welded. But the stiffened or the stiffening members of the bottom structure is also connected with the stiffening members of the side shell. That means this, what I see here, let me use this one. This, what you're seeing here, is a transverse frame. Okay. Also, we can call them as hold frames. Okay. This member is connected with the bottom structure with the help of this little bracket. Okay. This bracket. The sole purpose of brackets is to connect structures. Always remember, the stool that we were talking about, we had a top plate, we had the legs, and there were brackets connecting them too. Similarly, we have here a bracket which is connecting the bottom structure stiffening members with the side shell stiffening members. Okay, is it clear? That same
Yes, sir.
bracket is shown here. This one, this one. Now in the bracket, we have a hole, as we can see that. These holes are called as lightning holes. The reason they are called as lightning holes, because by making that hole, we are making the structure light. It's reducing some weight for that structure, and that is why the name is lightning bolts. Now these brackets, which are connecting the bottom stiffening members with the side shell stiffening members, are called as margin bracket. Some textbooks they call it as margin bracket. Some textbooks they prefer calling it as a tank side bracket. They both are same, but in your exams point of view, questions will be asked usually like tank side bracket. This is the standard connotation of that. Now, on the side shell, we have stiffening members. But all the stiffening members, all the transverses, these are the transverses. Okay. These these transverses, all transverses are not of the same thickness, not of the same size. Okay, we will have mostly like maybe one or two we will have of. Sorry, is there a question? Are you asking something? Someone spoke. Okay, maybe that was by mistake. So we will have one or two maybe of smaller size called as the hold frames, and after that we will have a bigger structure which we called as a web frame. These web frames and hold frames, they all can be classified as transverse frames only. Remember, because these are not longitudinal members, these are transverse frames only. Okay, but because of their size, they have special names attached to it. Sometimes in the exams, people they ask, what is a web frame? A web frame is simply a large sized transverse frame, and a hold frame is a smaller transverse frame, you can say. Okay. Now, once that is done, let's see. We have understood that we have to strengthen every component. Then we have to connect the components and the stiffening members. Okay. Now, in this picture, this section that we are seeing is of a. Can anyone say which ship section this is? You have studied about different types of ships. Any guess?
It's a bulk carrier.
General cargo.
General cargo is actually the correct answer, because let me tell you, bulk cargo, when you are taking a bulk carrier, you will have solid cargo, right? So you don't require two decks. But in case of general cargo ship, you will require multiple decks, because you cannot store everything on top of each other. There is always the chance of uh, cargo damage, and also you need access to those cargo, because general cargo ships may halt at multiple ports to kind of give out a little kind of thing. So yes, this is a general cargo ship. Now in this we have this this is a twin deck. Okay, so we have strengthened the deck. Here they have shown only a transverse member. So this member, this is the deck, and this is a transverse member under the deck. I will show you some pictures of these transverse members also, so you'll be more clear on that. And as we have done in the bottom case, we have added a bracket to connect the bottom stiffening members with the side shell stiffening members. Similarly, we will do that for deck as well. Okay. In case of decks, the transverse members are referred to as deck beams. Okay, deck beams are smaller transverse members. The decks, the way we have in case of side shell, we have web frames and hold frames. Similarly, for decks, we will have deck beams and deck transverses. Deck transverses will be the bigger members. Deck beams will be the smaller members. Now, each of these beams, we will try to connect them with the adjacent side shell transverse with the help of a bracket. Now, this bracket is called as a beam knee. Is it clear?
Yes, sir.
Okay. Now, in this picture, these things are the deck beams, and this thing is a bracket. Okay, so this is a bracket, and this is a deck beam. Okay, that is what is represented in this picture. I understand this was a lot to take up because there were so many new terminologies, but we will be discussing these same names again and again. So you will have a good practice of them. By the time we complete the syllabus, you will be thorough with it. Do not worry. Okay. And yes, one more thing I did not say. That is the way for the bottom. For the bottom plating, we had a center girder and we had the side girders, right? And we understood that the side girders are called as intercoastal side girders because they are intercoastal in nature. Okay. Similarly, decks will also have girders. In this case, we cannot have a center line girder because we have a hatch opening. Okay. So that is why wherever till whatever position the deck is, over there we have a longitudinal member. This is a longitudinal member, and this is a deck girder. It is also referred to as hatch side girder because the hatch starts from there itself. Also, we can call it as a deck girder. This is all about it. Now, these things will be really easier for you if you note down some points while we discuss because these things are not given in books the way I'm telling you. Okay, and I cannot put whatever I'm saying into words because it is easier for me to draw here, show you, and tell you. If I make a paragraph out of it, it will be jumbled up. Okay. Now, do you have any questions on this? Any clarifications you need?
No, sir.
No, sir.
Okay. So we have a small activity. Now, some of them maybe you will not be able to answer, but some of them you can. For example, what is number 8? What is number 8? Anyone?
Deck beam.
8 is actually the deck. It is referring to the plate. So it is only the deck. Okay. What is number 1? Sorry, you're not audible.
So stiffener.
Yes, stiffener. I mean, everything is a stiffener, but this one is actually the deck beam. That is why I asked you. This is a beam. Okay. So, okay, let's see. What is number 5? What is number 5?
Center girder.
Sir, nail.
Keel. Keel. It is a
Keel.
keel. Keel. Center girder is this vertical plate. This vertical plate is the center girder. Okay.
Yes, sir.
Now, okay. What is number 2? What is number 2? If I show you the previous picture, will you be able to answer?
Yes, sir.
Yes, sir.
Okay. What is number 2 then?
Yes, sir. Transverse frame.
Yes, it is a transverse frame. It is a transverse frame. Okay. So what is let's say what is 4? Can you say what is 4? Number 4. Number 4.
Oh, is it inner bottom?
Yes, it is the inner bottom. Very good. It is the inner bottom. Also, it has a different name called as tank top. Because whatever we have space below the inner bottom, they all are tanks only. That is why we call it as a tank top. Okay. Now, what is number 6? Did we name number 6? Let me see. We have a name for
So
number
floor.
6. Floor. Very good. So let me use a different color. This one is a sorry. 4 nahi hai wo. Number 6 is floor. Okay. Number 4, we are done. Number 9, anyone wants to take a guess? We have not studied this today. Anyone wants to take a guess?
So
Number
bulkhead.
9. Very good. It is a bulkhead. And number 7, what is it? What is number 7?
Side plate.
What is that?
Side plate.
Actually, your voice is not clear. It's breaking.
So he's saying side plate.
Not side plate actually, side shell. Okay. Side shell. Actually, when you say plate, plate basically refers to a smaller region. Okay, that is why we refrain from saying plate. Side shell is a combination of plates. Okay, are you getting that?
Yes, sir.
Yes. So this is about side transverse framing. Now we will move on to longitudinal framing, but after studying longitudinal framing, we should be able to compare transverse framing and longitudinal framing. Okay, keep that in mind. We will try to compare and understand if there are any pros and cons between these two. Okay, that is something we will try to do. So this is a graphical representation of roughly how the transverse framing is. Okay, not necessarily, do not think that these are put in the same manner. They have been separated just to show you how they are. Okay, we have quite a few girders in the bottom structure, and we have a lot more transverse members. Also, here, do you remember we talked about racking? Do you remember?
Yes, sir.
Now, during racking, we talked about that we need to have a good connection, strong connection between the side shell and the deck, isn't it?
Yes, sir.
Yes, sir.
Yes. Now that is when we said if we have if we can have a stiffener which is passing from the side shell to the deck, that would be strong. Now these ring kind of structures that you are seeing, these ring kind of structures are the ones which keep each of these components, that is the side shell integrated with the bottom, side shell integrated with the deck. Okay, so this ring is made out of See, we have floors in the bottom. Okay, the floors are connected to the side shell transverse frames with the help of a margin bracket or tank side bracket. Okay, and these tank side brackets are connected to the deck beams with the help of another bracket, which is called as a beam knee. Okay, so we have these ring kind of structures over the length of the vessel. Are you able to relate now why we have this kind of a arrangement in the ship?
Yes, sir.
Yes. So these floors that you are seeing, these floors will basically help us in overcoming those hydrostatic forces. The beams were trying to distort the shape of the hull. Now these floors will resist that. But if we have a long space unsupported, then the floor becomes weak. So these floors need support. For that support, we have added these girders. These girders should have been here actually. Here the girders should have been there. Okay. So these girders, they support the floors. So from here, you can say that the major structural items. What is the major structural item? One is the center girder, definitely. Then these floors. And what else? These are the most important major items actually, kind of. Rest all stiffeners, they are actually assisting them. In case of decks also, wherever we do not have hatch openings, we will have center line girders for decks also. Okay, and we will have those transverses. They say in this case, they have shown all transverse frames to be of same size, but that is seldom the case. Usually, we will have quite a few smaller ones, those hold frames. After a few hold frames, we will have a larger member, that is a web frame. That is not depicted here, which is why this 3D representation is not very accurate, but it is a good way of imagining things how they are. Okay. Any questions?
No, sir.
No, sir.
So finally, once we have added the side shell, this is how the structure is. Okay. So here I have just shown how um, the side shell stiffener, that is the hold frames, are connected with the bottom structure. Okay. We can connect them in multiple ways actually. Okay. One way is, let me show. When we are constructing the double bottom, okay, we can construct that in two ways. One is we have the hull. Let me show two different configurations on two sides. Okay. One is I can connect the double bottom to the side. Okay. The second one is I can end the double bottom here with a sloping plate. Okay. In this kind of a configuration, this sloping plate is called as a margin plate. This margin plate marks the end of double bottom. Okay. Now the stiffeners, the hold frames, they will be like this. They will be like this. If we have a double bottom which is flushed onto the side shell, I can just take a bracket like this, simple connection. They are connected. But if I have a margin plate at the end, that means the double bottom is not flushed onto the side. I will have to be trickier. I have to take a bracket which takes the shape of the hull like this, and like this. Okay, these are just two ways of connecting the bottom structure with the side shell transverses. Okay, the same thing is depicted here. Okay, in one case we have the tank top till the side, so we can just put a bracket, connecting the tank top with the side shell transverse. Okay, which is shown here. I mean, all these figures are same. On the left, these three, they are just like 3D, and on the 2D is shown in the right. Okay. And the second configuration where we had a margin plate is shown here. Okay. This is my tank top. It goes and ends like this. This is my bottom shell. And I have the transverse frames here. So I have connected them using a bracket. This is my bracket. Okay, this one. Just to reduce the weight of the structure a little bit, we have cut a hole in it. Okay. And this flange that they have written, the flange is shown here actually. We usually try to make a flange on the bracket to increase its bending strength. That's it. Is it clear so far? Any questions? Anything that you are not able to get?
No, sir.
Okay. See, if at all you are not asking something now, sometimes things can be overwhelming because we'll be seeing quite
Sir?
a few. Yes.
Sir, could you please share this PPT?
Yes, these all will be shared with you.
Okay, sir.
Yes, everything
Thank
that
you,
you
sir.
see in the class will be given to you. So,
Okay, sir.
yes. So sometimes you may have questions while studying because in the class it happens that when we see new things, we don't think a lot. But later on, if you have questions, you can always come back and ask. So that is possible. Now, so far we saw about uh, the bottoms connection. Here, I've tried to show the um, the beams, the deck beams. What you are seeing here is only focus on this picture now. We are talking about transverse framing. Below the deck, we have these members, transverse members. The transverse members, the smaller transverse members actually, they are referred to as deck beams. Okay. Also remember, I mean, no, this is not in syllabus. Let's not get confused. This is only, just remember them as deck beams. Okay. And these deck beams are connected to the side shell stiffeners as shown here with the help of this little triangular bracket which you can see, and that is a beam knee. Okay. So this is a typical transversely framed ship. That means you are not seeing a lot many longitudinal members. After this, when we move on to longitudinally framed structures, you will see the number of stiffeners goes very, I mean, it goes way up. We'll be having a lot many longitudinal. It will be a very clumsy kind of picture. We will see that also. So this is all about beams.
So, sir,
Beam.
the deck beams and the deck longitudinals are one and the same thing.
No, they're not the same thing. Actually, longitudinals are in the longitudinal direction. Deck beams are in the transverse direction. Are you getting my point?
Sir, but they serve the same purpose, na?
Yes, they serve the same purpose. You can say they are stiffeners but kind of the way we discuss now, we need that ring kind of structure always to encounter, to kind of resist those racking forces. In case of whenever we have a longitudinally framed structure, we will come to it. We will not be having deck beams. Instead, we'll be having much larger items. You see, this is a big transverse member. This will be called as a deck transverse. So we have eliminated all those small beams, and we have those bigger members. The way we had in side shell, those web frames, we will have bigger members. Because those ring kind of structures which we talked about, they are inevitable. We cannot avoid that because we need to be serious about the racking stresses. We have those transverse rings in every ship. The ship which we have in campus also, it has these kind of structures. Someday if you go on to it, you can see them. Okay.
Okay, sir.
Yes. So this represents how the deck beams are connected to the side shell stiffness. There are three types of combinations possible actually. When they in this case, it is easy because we have transverse beams. We have transverse members, so they are actually connecting with each other. Okay. So we have those little brackets. Okay, longitudinal wala I could have told you at the end, but now I'll just tell you. In case of longitudinals, we have to connect the way we have discussed. We have to strengthen each component and we have to ensure connection between the components. So when we have a longitudinal and a deck side shell transverse, we will take a long elongated knee, but we will connect them together. Unless and until the structural members are well connected, the flow of stresses will not happen. There will be stress accumulation and structures will fail. So that is why we ensure connection between those members. Okay. And these are beam knees. Beam knees are basically the brackets which connect deck transverse or deck stiffeners with side shell stiffeners. And tank side brackets connect side shell with bottom. You have to remember this. Okay. So coming to, yes, this just tells you what all the primary members are. Primary members means the main load bearing members in the structure. Okay. They are the web frames, the big ones, the deck transverses, the big ones, the solid floors in the bottom. Also the it should have been written here. But here we have only talked about the transverse members, which are the big ones. And the secondary ones are the little ones. The whole frames, the little ones, the deck beams, the little ones, and longitudinals, if any. There may be no longitudinals also. Let's not talk about this now. Yes. The next one is longitudinal framing system. In longitudinal framing system, the way we talked about the sticks, which stick is easier to break, the small one or the long one, when the ship's length exceeds usually 120 meters, then the longitudinal bending moments, they increase. Because of that, it is really important that we go for longitudinal framing system. In longitudinal framing system, there will be less number of transverse members and more number of longitudinal members. But transverse members will be there. Always remember that when we say longitudinal or transverse framing system, मतलब transverse framing system में there will be longitudinal members but less in number. Similarly, in longitudinal framing system also there will be transverse framing members but less in number. Okay. One big demerit or one big disadvantage of longitudinal framing system is these framing systems, they eat up space. What the meaning of that is? Let me show you. Let me show you this one. Yes, here. See, this is a transversely framed ship. Okay. In this, if you notice, wherever we will have a, suppose I have a web frame here also, a big web frame. But the thing is, between two transverse members, I have space available till the side shell, isn't it? Are you getting my point?
Yes,
Yes,
sir.
sir.
Yes. But when we have a longitudinal framing system, the longitudinals will pass over the length, over the length. So that space which we had here in case of transverse framing system is actually permanently blocked. So that thing is a demerit of longitudinal framing system. Technically, we say that longitudinal framing system reduces the bale capacity reduces bale capacity of ship. By bale capacity, what it means is, try to understand this. Suppose I have a box. I have a box like this, and I have a box maybe of this shape. Let's say that in both these spaces, I have the same volume. Okay, this is a prism actually. On the left, what I've shown is it is an elongated triangular structure, so it is a prism kind of thing. So both of them, they have same volume. So if I put water into both of these things, I can say that because the volume is same, they both are having the same capacity of storage, isn't it? Right?
Excuse me, sir.
Yes.
So could you define bale capacity again?
No, I have not defined it yet. I am trying to define that. I'm on the way.
All right, sir.
Yes. So these two spaces, they have the same volume. If I try to put water into it, now because the volume is same, we can say that they both will have the same amount of water in them, isn't it? Am I right?
Yes, sir.
Yes. Now think of it this way. I have cube shaped small pieces. A lot many these types of pieces. Now, do you think I'll be able to fit same number of these pieces into both of these?
No, sir.
Yes. Now that is what bale capacity represents. That means, suppose we are taking cargo of say cubical shape or cuboidal shape, will we be able to keep them? If we have those longitudinal members passing throughout, though we have volume available, but we cannot fix our cargo into it. Are you getting my point now?
Yes, sir.
Yes. So longitudinal framing capacity reduces the bale capacity. Framing system reduces the bale capacity. Bale capacity means the capacity of a space to kind of hold a uniformly shaped object. When we are talking about liquid, suppose we are talking about a oil tanker, we are not bothered about these things. But suppose we are talking about a general cargo ship. For a general cargo ship, this bale capacity matters. We will come to it as to how we can avoid this problem after some time, or maybe tomorrow. No, tomorrow we will come to it. Okay. So This is a problem with longitudinal framing system, but it will not stop us from using it, because when a ship's length is more, you are not worried about the bale capacity. You are worried about the safety of all the cargo. You need to have that much amount of strength, and there is no compromise in it. So you'll be going for longitudinal framing system. This longitudinal framing system looks something like this. Okay, it is slightly complicated. We will try to understand each and every part of it. Now, mm, okay, see, let's approach it in the same manner. First of all, let me tell you, this is a single hull ship, what you are seeing, and it is not the only diagram possible. We can always draw a double hull ship also. But here, in case of your book, whatever is given, I've added the same picture so that it will be easier for you to read also. Now, let's see. I have the bottom plating. Okay. If you remember, we talked about, we have the bottom plating. At the center, we will have the keel plate. And on the keel plate, we will have the vertical center girder. Okay. Is it confusing this way? Do you want me to maybe draw it kind of, or is it okay, understandable? Do you want me to put lines on it, or only laser is okay?
So it's all right.
That's okay. Okay. So, okay, let me put some lines also. It will be easier maybe. So we have the bottom plating of the ship. We know that at the center we have the keel plate. Okay. Somewhere here will be the keel plate. On the keel plate, we will have the vertical center girder. Okay. Now, in this case also, we will have the transverse floors, which we discussed, but it is not shown in this particular section because transverse floors, as we discussed, they occur at some intervals. Okay, the place where this section has been taken, there was no floor. Okay, so that is why they have not shown a floor here, but actually there lies a floor. There will be a floor in this ship also. So we know that to support that floor, we need some side girders, which are intercoastal in nature, and we know that. Okay, so we have one side girder, one side girder. It will be the replication on the other side. So we have one more side girder and one more side girder. Once we have done that, we are stiffening the ship longitudinally. So we will go on adding a lot many longitudinals. Okay. Longitudinals, a lot many longitudinals. As I told you earlier, if you are worrying about how many longitudinals are to be put, nobody knows that. It is a hit and trial process. We make a calculation in the beginning as to how much amount of load the structure should be capable of taking. On the basis of that, we will add the stiffeners, we will run our calculations. Are we able to achieve a certain amount of section modulus? If not, we will add more stiffeners. If adding more stiffeners is also not helping, we will increase the thickness of the stiffeners and so on. It is an iterative process. Okay, so that is how it is designed. Now, also one more thing. In this case, the stiffeners are shown for the bottom, they are shown as T sections. It is not mandatory for you to draw anywhere, if at all it is asked in the exam, to draw T sections. Okay, you can draw a angle bar the way it is shown in the side shell. You can draw bull bars and on. We will see later what all different types of sections are there. Before we move on, I want you to take a guess what type of a ship this is. Take a guess. Anyone?
Container.
Container? No, unfortunately, no.
Roro ship.
Roro ship? No, actually. Any other guess? Previously, you were right when you said general cargo ship. Take a guess. See, this ship does not have a hatch cover. Which type of a ship will not have a hatch cover? Container ships will have hatch covers, right? What is this?
Oil tanker.
Oil tanker. Very good. Very good. This is a tanker actually. Because if we had a hatch cover, we would not have the deck center girder, right? That is why. So, yes, let's move on. So, let me see what time is. Your CR is ready with the number of absentees, right? I don't have to worry about it. Am I right? If not, I will have to end soon and call out your names. That is why I'm asking. Please tell me.
Oh, so I'll record the attendance.
Acha, okay. Then we can move on for another 5 minutes. So we have these bottom longitudinals. Once we have put these girders, also one more thing. You can always ask why these are girders and why these are longitudinals. Both are longitudinal members, but girders are little bigger structures. They are also longitudinals. These bottom longitudinals are also longitudinals. But girders have a different name because they're bigger in size. The way we had for transverse frames, we had hold frames and web frames similarly. The girders are the bigger longitudinals. Okay. Similarly, for a deck also, you will see we have the center line deck girder. We have the side girders. Okay. And we have deck longitudinals. Basically, longitudinals are little smaller members and girders are bigger members and primary structures. They're load bearing members. Okay. On the side shell, what we have is like actually this picture is slightly confusing because of the section they have taken. It's not like it will only have this longitudinals. At some intervals, it will have web frames also. Okay. These are longitudinals. Okay. Now, in case of, because this is an oil tanker, what happens is oil tanker, we are carrying liquid. So because of the motions of the ship, the water will start splashing. आपने देखा होगा in the bottle, if you have not completely filled bottle, it is slightly empty at the top. So if you move the bottle once, the bottle keeps slowly, kind of, it moves like a pendulum, right? Have you noticed that? Have you noticed?
Yes, sir.
Yes. So that effect is called as free surface effect. Okay, that is called as free surface effect. To reduce free surface effect, what we do is we reduce the breadth of the tanks. To reduce the breadth of the tanks, we introduce longitudinal bulkheads. And because a bulkhead cannot be on its own, it has its own stiffness, the longitudinal stiffness. Now, tell me why all these stiffeners are facing down. Do you have any reason for it? Here also facing down, here also facing down. Why is that the case? Take a guess. Any guess? Anyone? Just think of it. We are carrying oil. What will happen if we have those stiffeners up? Anyone? No? No guess?
No, sir.
Okay, think of it. If I tell you, if I draw it out, you will understand. Diksha. This is a bucket. Soch lo. We have oil in it. Okay. Now, how you are taking oil out of it? You're pumping out, right? You're not exactly like a bucket. You cannot turn it over and spill out the oil. So here I have a stiffener like this. Here I have a stiffener like this. The oil was still this. Okay. From the bottom, I had a manifold. I pumped out the oil. So what will happen? How will these, what is that? Tell me again.
It's a little bit oil will be there only left.
Yes, very good. See,
But then
this is
suffer.
yes. So there will be little bit of oil accumulation in this space. If we keep the stiffeners facing up, now that little bit may sound little bit, but when we have this many number of longitudinals and over the length of the ship, it is going to be a considerable amount. And how are you going to clean it? So that is why we will prefer keeping the stiffeners facing down, okay, to remove this problem. See, ship construction is a very logical kind of subject. You just have to think of it in a practical manner and relate it to some lively examples, whatever you have seen in your life so far, and you'll be good to go. This is simple or not so far, whatever we have seen.
Yes, sir.
Yes. So let's stop here. Tomorrow we will start from this drawing itself. Okay. Just it will be very easy for me if you can remember this so that you can tell me at least where we should have started. So tell me where who all are absent.
So I texted you the absentees of both.
Just a minute. Just a minute. Okay. I am your numbers of the absentees. Okay, just a minute. कहाँ गया?
So can you reconfirm the numbers so that there is no
No, I will
problem?
open and I'll show you that. I don't want to do it in this manner. Okay, I have closed your attendance maybe. NS na, correct. Yes, division 2, right? Okay. So the messages, see 041